Okay, so this is a video on the general basics of chirality. I'm not going to go into every single little detail, and I'll put out more videos on um, certain examples of problems. But first, let's get into it. So, what does it mean to be chiral? So, something that's chiral is something that has a carbon, and that carbon specifically has four different things attached to it. That's just a very, very basic definition. In reality, something that's chiral is a chiral center is a center of carbon on a molecule that rotates plane polarized light a certain way, right? Either right or left. I think these are German words or Latin. I don't know, but R is right, S is left. Okay. And so chirality is important because one molecule might have an R center while the other one has an S center, right? So the R isomer of limonene gives oranges its smell. The S isomer gives lemons its smell. So this is why chirality is important. It's important for a lot of different things. It shows itself up in nature a lot. It's important in drug research and a bunch of stuff. So this is why you're covering it. Okay, I just wanted to say that because this can be a little bit difficult for some people. So I don't know, anything to kind of at least make it like connect to the real world. So four different things, four different groups. Okay, so now I want to talk about what categorizes something as different. Okay, so I might have a bunch of examples here, including this little ring that's going to be a nice special example because you don't see any problems like that on the in the book. So it has to have four different things. So let's look at all of these carbons, right? Okay, this carbon has a hydrogen, and a hydrogen. Off rip, that's not a chiral center because it has two of the same thing. It has two hydrogens. It can't, a carbon that's a chiral center cannot be attached to two of the same thing, right? Okay, so that's not a chiral center. What about this one? Okay, this carbon, it is attached to a carbon. It is also attached to another carbon, and it's attached to a chlorine, and there is a hydrogen in the back. Okay, now we have a tie, right? We are only focusing on what this carbon is attached to, aka a direct connection, right? When we're trying to figure out what it's attached to assign priority, right, which I'll talk about once we discuss like more about chiral centers, we need four different things. So we have a chlorine, hydrogen, we have a carbon, and a carbon. So we have a tie between these carbons, okay? And so because we have a tie between these carbons, we have to move to these carbons. And now we got to figure out, okay, what's attached to these carbons that can possibly break our tie, right? Okay, let's say carbon A and carbon B. On carbon A, we have three hydrogens, okay? Carbon B is directly connected to an oxygen and another carbon, right? Carbon B is connected to this O, and that O is connected to an H. But carbon B is not directly connected to this H. I hope that makes sense. It's only connected to the O. And then it's also directly connected to the carbon, right? So when we assign priority, we can figure this out. But now we know that carbon A and B are in fact two separate things because they have different stuff on them. Okay, I know this is like super messy, but I'm gonna erase these because it's just not enough space. But we now know carbon, sorry, this one is a chiral center. Okay, let's go to here. Okay, this carbon is directly connected to an oxygen, a carbon, and another carbon. Okay, so there's a tie. Oh my gosh. So we got to move to these carbons. Let's go to carbons A and B again, right? A is connected to, see if I can find a bright color. Okay, pink. Connected to a chlorine and directly connected to a carbon. Hold on, I'm just going to erase these. This is just too much. Okay, a carbon, right? So, chlorine, carbon. B is directly connected to three hydrogens. Sorry. Okay, so now we know this carbon is a chiral center because carbon A and carbon B are attached to different things. Okay, again, I'm just gonna erase these. You guys can pause the video and stuff. Okay, so chiral center. And you notice when I do these problems, now I don't do this because I do it in my head, but when I would do them, I would list in just on the side what it's attached to. Okay, we got a Cl, we got a C, we got a C, just to keep track of things, right? Organic chemistry, you want to keep track of stuff. Okay, so now that we know that these are chiral centers, right? This one is not going to be a chiral center because this has more than two things, right? It has three hydrogens, right? Okay, so I'm gonna be honest. This is actually taking a minute. I will probably come back to these in in the next video. Okay, so but we're getting some good learning done. All right, so chiral centers and whatnot. All right, so now we are going to assign priorities. Okay. Okay, so let's go to this chiral center. Wow, sorry. Chiral center 1 here. Okay, so priorities are assigned by molecular weight, right? So we just got to figure out how much, like, what's the weight, right? And so for something to be priority number 1 versus number 2, that means it has to weigh more. Whatever's connected to it has to weigh more than 2, right? And thus for 2 and 3, whatever's connected to 2 has to weigh more than what's connected to 3. And so that's how you determine it. Okay, first off rip, hydrogen is 4. If there is a hydrogen connected to your chiral center, it's going to be 4 because there's nothing less than that. But number 4 does not always have to be hydrogen. That is an important thing to note. Number 4 can be a carbon. Number 4 could be chlorine. It's all depending on weight, okay? So direct connections, right? We have a chlorine, a C, and an H, right? And one of those C's has 3 hydrogens, and one of those C's has an O and a C, right? Okay. Off rip, in as far as direct connection is concerned, chlorine is number 1. Okay? Because direct connection is only a carbon and a carbon. We're not directly connected to this oxygen and all this other stuff, right? We're only directly connected to that carbon. Okay? So, chlorine's 1. And now we got to move to these carbons, right? That tiebreaker is going to tell us our next priority, right? We're trying to figure out 2 and 3, okay? And so B is going to end up being 2 because it's a carbon that has an oxygen and a chlorine. That's 16 plus 12. I did my math right. Okay, awesome, because I'm bad at math. This one, it just has 3 hydrogens, which is just 3. So 28 and 3, 28's way higher. Okay, so that's how it works. That's why those tiebreakers are important. But it's also important to keep track of stuff, unless you can do it in your head. Okay, so now we have our order of priority. We have 1, 2, 3, and then we have our 4th. Okay, so we have to figure out if this is R or S, right? R means the priorities go in a clockwise direction. S means the priorities go in a counter. You know what that says. Okay. Counterclockwise direction. Okay? So it has to go from the highest priority to lowest. All right? Just put your hand over 4 and go 1 to 2 to 3, right? So you put your hand over the lowest one, because you can't, it's hard to imagine it. So you just ignore it, right? And that's just the like rule of thumb for these. You just ignore 4 and do 1 to 2 to 3 to figure out your priority. And it's going clockwise, so it's R. But we have a stipulation with chirality, okay? If priority number 4 is in the front, aka wedged, you flip the R and S. Okay, so we found this R and S to be, well, we found this chiral center to be R, right clockwise. Okay, but once we find the chiral center, this is what I always do. I find the chiral center, and then I look back and I ask myself, okay, is number 4 in the front or the back? If number 4 is in the front, I have to flip it. And 4 is in fact in the front, so it flips to S. So our official chiral center is S. Okay, now we're here, right? OH is 1. The carbon with the chlorine and the other carbon is 2. You can just, if you do this enough, you don't have to do this step by step. Now, I would encourage you guys to start doing that now, just a step by step, so that you can just automatically start doing them quickly. But go slow and do them step by step and familiarize yourself with how you do it in the process, and then start, doing it fast. So 1, 2. If you don't understand the 2 and the 3, just pause it and work through it in your head. 2 and then 3. And then we also have a hydrogen in the back. Do not forget what's in the front or the back. He's not going to give you both dashes and wedges. That's just too easy, right? And so 4 is in the back. So we don't flip it, right? So we're going to go, let me get another color, yellow. 1 to 2 to 3, and that's going to be R. It's going to go like that, right? R. So, oh my gosh, this is so messy. Okay, so the official name for this molecule, and you might have to know the name, is 3R, 3-chloro, 3R, my bad, I'm out here playing big games, I'm just jumping. Okay, 3S, 2R, 3-chloro, 2 butanol. Okay, I'm sorry. Sometimes I'm just rusty. Okay, well, what does that mean? 3S, as in, on the 3rd carbon we have a chlorine, and that chiral center is S. 2R, as in, on the 2nd carbon we have a alcohol, and that chiral center is R. So that's how you name these. So, Rafael, answer is 3s2r3-chloro-2-butanol. And that's the general gist of how you would just do a chiral center. This seems like a lot of steps, but if you go through them methodically as you go through the homework, and I would start ASAP, if you just do that one time through, when the second time you go through those problems again, you'll see yourself having to do it a little bit less. The third time, you know, and hopefully you're going to do these problems multiple times, it'll be a little bit less. And so if you keep going back to it and keep sticking to your guns and keep sticking to the step-by-step plan, you'll figure it out. And now I'm going to make another video on the enantiomers, diastereomer stuff. But I just wanted to do a general one on chirality to just give you guys something to watch.